Hi there, and thanks for tuning in and listening to me, Steve Hayes, as I talk to you about integrating wireless technology into a host product. This presentation should last about 30 minutes or so as I guide you through all the different aspects of integrating that radio module or wireless product into a host product itself. So, with no further ado, let's get on to the next slide and get into the detail. So in this presentation, I'm going to cover what is a radio equipment, and that varies depending upon whether you're looking at this from a European perspective or a North American perspective, and then into the nitty-gritty then of what do you do when you actually integrate a radio module. What are the consequences of the host equipment, what are the consequences or requirements of the radio module itself, and then lastly I'm going to leave you with some takeaway messages. Okay, so in terms of radio equipment themselves, there are many different types of radio product that we see on the market. Some are covered by what we call the Radio Equipment Directive, the CE marking regulations that cover placing of radio equipment on the EU market. So there's the classic Wi-Fi router or router, two-way radios, radio products that you may argue look like a radio module there, and we'll talk about that in a little bit more detail later on. Then broadcast equipment, whether that be AM, FM, DAB, radio, as well as terrestrial or non-terrestrial satellite receivers like set-top boxes and dishes, those sorts of things. And then products which are radio equipment where the host doesn't then necessarily need to be CE marked. So if we took footwear, for example, where you might have a radio device embedded in the footwear to record how many steps you've done, clearly that is a radio product itself, and that bit needs to be CE marked against the radio regulations, but the training shoe, the shoe itself, does not need to be CE marked. Likewise with vehicles. Vehicles are very complex electrical products these days and full of radio, both broadcast receivers, transmitters of all descriptions, and some of those are embedded into the functionality of the vehicle itself, things like radar, parking sensors, all those sorts of things. All of those items of radio equipment need to be CE marked to the radio regulations. However, you won't find a CE mark on the vehicle. The reason for that is vehicles are covered under what's called type approval legislation, where the national authority issues the type approval certificate. So we often see on vehicles an E mark, a large E followed by a small number. The large E indicates that it has been E-marked. The number indicates which country issued the certification itself. All of the regulations on vehicles relate to making sure that the driver, its occupants and other road users are or remain safe. So it's all about safety. When we think about radio equipment in the US and Canada, so North America, we still have all of the same products at the top, which are covered under the radio regulations. However, we don't certify broadcast transmitters, receivers, sneakers, training shoes and vehicles. So the scope of radio regulations in North America is subtly different for certain categories of products compared with Europe. Now, for all of the presentation that I'm doing today, I am focusing just on Europe and North America. The reason for that is because many of the other regulations, radio regulations around the world, derive their requirements either from the European or North American models. So when we're thinking about equipment in the US, the FCC, the Federal Communications Commission, are the federal regulator of electrical products. Electrical products basically fit into the unintentional radiator category, meaning that yes, they might produce electrical signals, and yes, they might radiate, but not intentionally. So a desktop computer, for example, would be considered as an unintentional radiator if it didn't include things like Bluetooth and Wi-Fi modules in them. So just a really basic type of computer. Included in that scope as well, unintentional radiators, we also have IT equipment such as the desktop that I just mentioned, and also radio receivers, so broadcast receivers. On the other side, we have intentional radiators. These are radiators where we intend to radiate signals from them, and they cover both licensed and unlicensed transmitters. So when we say unlicensed, it means that as consumers, we don't need to individually have a license to operate that particular type of device. So a Bluetooth, Wi-Fi, garage door opener, all of those sorts of things, we as individuals don't need a license to operate them. So we call them unlicensed, as opposed to licensed transmitters, which typically the owner of that part of the spectrum, so if somebody bought that bit of the spectrum from the National Administration, they own that bit of the radio spectrum, it's licensed to them, and they control what products and devices are allowed to be operated in their bit of the spectrum, so covered under different FCC rule parts. In brackets on the right hand side there, you can see the ISED requirement. So ISED is the regulator for Canada, and RSS are the radio specification standards that relate to each of those unlicensed or licensed devices. In reality, IoT products are a combination of intentional and unintentional radiators. If you think about most use cases, take your laptop as an example, the desktop PC. It is a combination of, a motherboard with a hard drive, processing functions, keyboards, all of those sorts of things which are unintentional radiators, but of course have Bluetooth, Wi-Fi type modules embedded in them as well. That means that they come under both unintentional and intentional radiators, so we'll have dual approvals to go through. I'll talk about that in a little more detail shortly. In Europe, we, rather than calling them intentional radiators and unintentional radiators, we either have non-radio equipment or radio equipment. Non-radio equipment is clearly not a transmitter, but equally is not a receiver either. It includes ISM, so industrial, scientific, medical equipment, so products which intentionally transmit radio waves, but not for the purpose of communication or determination. And then we have electro-discharge machines, which again use RF energy for the treatment of materials themselves. So again, transmitting, in this particular case, very high power RF energy, but not for communication. And because both of those categories don't communicate, they're considered as non-radio, as opposed to radio equipment, where, as I say, it's anything to do with communication or radio determination. Anything that contains radio equipment is also covered under the radio equipment. So in those previous examples with cars and sneakers, but all of those other products, the host equipment, if you put a radio module, as we often refer to them as, if you put a radio module in something else, then it's the something else then also becomes radio equipment. So in the reality, most IoT products again are radio equipment. So when we're talking about regulatory, I said that this presentation would focus predominantly on the US and the EU, and which it does, and then also Canada. And from a regulatory perspective, we often joke that Canada is somewhere in the mid-Atlantic. So it's a halfway house really between the US requirements regulated by the FCC and the European Commission's Radio Equipment Directive. So we're using RSS standards, and some of the processes and procedures look more like European ones than they do North American. So, I mean, just a small correction. When in the last slide I was talking about EU regulations, I am actually talking about European regulations, because there are some countries in Europe, in the geographic area of Europe, that are not part of the EU itself. So the UK, many people will be familiar with Brexit, for example. So the UK is no longer part of the EU, but equally there are other countries in Europe that are outside the EU as well. The big difference, however, is that those non-EU countries that are still based in Europe adopt CE marking, whereas the UK is slightly different in that it recognises CE marking, but in a slightly different way. So if we compare the philosophy, if you like, between the different radio regulations, whether we're talking about Europe or North American, we're talking about radio versus non-radio, as opposed to intentional versus unintentional radiators for North America. We have a single entity in Europe, the European Commission, which is responsible for consumer health, safety and environmental protection. Whereas in North America, we have the FCC that look after the radio spectrum, for example, but then we have OSHA, which is responsible for regulating the safety of products, and we have the FDA responsible for regulating medical devices. So multiple regulatory bodies in North America. In Europe, it's one single badge, and all of the laws derive themselves from the European Commission. In Europe as well, we have a process called self-declaration, the process by which a manufacturer declares that their product meets these legal requirements, and typically it's not checked by a third party. The manufacturer follows what we call conformity assessment procedures, and as long as they follow those procedures, then they can self-declare their product against the different regulations or directives. In North America, whether it be the FCC or ISED in Canada, it is a process of certification. So the manufacturers go and do the testing, but ultimately it is the certifier, so the FCC or ISED, that issues the certification themselves. The manufacturer is not allowed to do that themselves. The other big difference is that in Europe, the regulations, so whether it be a CE marking directive or a CE marking regulation, they really are non-technical legal requirements. They're more philosophical. So, for example, the Radio Equipment Directive will essentially say, thou shalt make radio equipment which does not cause harmful interference and is safe. Whereas in North America, a lot of the technical details, the limits, the specifications, if you like, are contained within the legal text itself. Europe's much more about design a product and make it safe. How you, as the manufacturer, do that, you're given a certain amount of flexibility as to how you demonstrate that something's safe. You do whatever you need to do to prove that it's safe before you place the product on the market, as opposed to North America, where the regulatory text tells you exactly what you have to do. There is no ambiguity, but it's a very stringent set of rules that you must follow and adhere to. So again, just slightly different nuances between Europe and North America. So if we think about Europe, I just said that the directive or the regulations don't contain any any technical details, which is true. They set out what are called essential requirements. The essential requirements are the law that manufacturers have to comply with. For example, thou shalt make safe product. How you demonstrate that it is safe is dependent on the nature of the product itself. So it's expected that a manufacturer will do an analysis of the risks relating to their product, the way it's used, where it's used, who's using it, and then they will perform some testing. Many of the what are called harmonized standards contain all of the different hazards associated with the phenomena, and the manufacturer is expected to make a check to ensure that all of the hazards that they've identified in their risk analysis are contained in the standard and therefore the testing that they do. If they're not, or there's any additional requirements, then the manufacturer is meant to identify those, provide a technical rationale and mitigate those deltas by doing something else. That might be some calculations, it might be some testing, it might be some simulation. But they just need to identify the risks and mitigate those risks by taking some action. If I come back to the middle, I said the essential requirements are the law, but equally in the front of all the directives and regulation there are some whereases. That's legal text that provides some context as to why the directive's there, what really it is trying to achieve, what its objectives are, and to help the reader of the law understand better the context in which they're operating. And then all these directives typically contain annexes, which are some supplementary information. They might be telling manufacturers which modules to follow. Can they do self-assessment? Do they need to involve a notified body? Maybe there's a quality aspect to it. Maybe there's some additional information that's in there as well. Those are typically contained in the annexes. And then on the right hand side, having done all of those two things on the left, there is a body of evidence that needs to be produced. And that evidence contains all of the technical documentation, declaration of conformity, which is the manufacturer's declaration that they declaring that their product meets the requirements of this particular regulation, and also if a notified body has been used, the notified body type examination certificate. The concept of this dossier of information or evidence on the right hand side is really that it can be handed over to a market surveillance authority, and it should contain everything that's in there to explain what the manufacturer has done, why they've done it, and all of the evidence to say that it meets the requirements of the directive itself. Under the Radio Equipment Directive, there are a number of different articles requirements. So Article 3.1a relates to safety, the safety of the product itself. So it takes another CE marking directive, the Low Voltage Directive. It removes the lower voltage limit, so everything from 0 volts upward is then contained. And the idea is that it's a series of assessments that are done on the product itself to demonstrate that it's safe to use. The next article, 3.1b, is covering EMC, electromagnetic compatibility. And that really ensures that the product itself will work adjacent to other electrical equipment and won't cause harmful interference to other users of the radio spectrum. And then the last one is radio performance. Radio performance to make sure that it's on the right frequency, occupies the right bandwidth, power levels. It might have some receiver tests, which I'll talk about a little bit later on as well. And it's all to do with, again, stopping harmful interference through the characterization and measurement of the radio characteristics of the product itself. Additionally, there are other categories, so a number of articles, so 3.1 D, E and F cover things like cybersecurity, prevention of fraud, these sorts of devices, and depending upon the product, are going through a transitional period where some of those things will be adopted by August 2025. So make sure you check back in with Element in case you're covered by any of those, and keep updated on the transitional arrangements. Last one in terms of requirements is the common charger, that's Article 3.4, and that applies to cell phones where we have standardized on, for example, USB-C charger, and it's a piece of environmental legislation aimed at minimizing overproduction of multiple phone chargers and associated cables. So in terms of the Radio Equipment Directive Declaration of Conformity, the notable thing here is that it's one declaration of conformity that applies to the same or the final product. So it may be that you had a product, let's call it a medical radio device. A manufacturer would still only typically produce one declaration of conformity, because ultimately it's only one CE mark that will be put on the product itself. They might be tested separately or individually, but there is one declaration that covers the product that gets placed onto the market itself. The other thing to note is there's no red certification. Manufacturers often come to us and say, I need to certify my product to the red. That's not quite strictly true. What they need to do is declare their product as compliant to the red. And the reason I'm making that distinction is obvious when we start talking about North American approval and the certification that's required there. So if we go to the FCC and the requirements there, we have RF exposure requirements, so making sure that the RF is limited such that it complies with both FCC requirements and international radio protection requirements. EMC, but again, we call EMC in the US, in North America, but what we actually mean typically is the emissions from products themselves, what it has emitted. And then lastly, I should say, the radio performance. So again, similar to Europe in terms of, is it on the right frequency, power, bandwidth, all of those sorts of things. What we don't do for North America, though, are what are defined really, I guess, as quality tests. So this is more about the receiver side and how selective they are at ignoring intentional transmissions which are not intended for it. So there are no receiver tests currently required for FCC approval. And again, the FCC don't regulate the safety side of things. That's OSHA's responsibility, which leads to different badges ultimately placed on the product, which are covered by OSHA requirements and delivered through what are called NRTLs, nationally recognized test labs. So you have a different badge for safety compared with its radio badge, which is regulated by the FCC. So in terms of the different FCC rule parts, we have Part 2, which applies to all products, Part 15, which is to do with radio frequency devices, Part 18, which is to do with ISM, and then Parts 22 through 96, which is covering different types of licensed transmitter. So different sections of part or the FCC rules that apply. There are two routes to authorization for FCC. The first one, which relates to unintentional radiators, is called a Supplier's Declaration of Conformity, SDOC. So that applies to all electrical or electronic related products and most receivers. Unlike Europe, when we say Supplier's Declaration of Conformity, it's not a physical declaration that manufacturers do, it's just a process that they follow. So in Europe, the manufacturer has to sign a piece of paper that says, I declare that this is compliant. That's not the same for North America, or sorry, for FCC. SDOC route is just a process which is followed. The other process which is followed is the certification route, and that applies to most radio transmitters. And in terms of certification, it's issued for the FCC, either directly by the FCC, which is pretty unlikely these days, or in 99.9% of the cases through what's called a TCB, a telecommunications certification body, such as a company like Element, where we're empowered by the FCC to make sure that manufacturers have done the right testing, compiled all the right documentation, and then we issue the certification on behalf of the FCC themselves. For Canada, as I say, Canada is just a little bit different. So I said, in terms of labelling and comparing it to FCC, you'll see at the top we have a IC and an FCC ID. So these are physical certification identifiers that have to be applied to the physical product itself. And then for Canada, we use RSS standards for testing of radio transmitters and ICES standards for testing of non-intentional radiators typically. We have to assess both the radio and non-radio parts of the device, and then the certification, a little bit like the FCC, is typically assessed by a foreign certification body or a domestic certification body if in the case of them being in Canada. But then the ICED themselves get involved, and ICED provide the listing of all the certified devices on the Canadian market. For FCC, we talked about the FCC rules, and that's where all the technical details will be found, including frequencies and levels and tests which are required. The FCC rules themselves cover all of the radio and non-radio parts of the device, and as said before, that the certification is issued by the TCB immediately, as opposed to having this extra step with ICED where they then double check what the FCB has done. So if we look at the radio aspects of when we integrate radio equipment into host equipment. First of all, we need to identify what a radio module is as opposed to a chipset. I'm going to be talking about radio modules, not chipsets, simply because chipsets are components, and components are typically excluded from all of these different requirements. Because you have to connect the chipset up to other peripheral components, a power supply, antennas, all of those sorts of things, there's so little you can actually assess from a regulatory point of view on a chipset. They're typically outside the scope of the regulations themselves. Radio modules, however, could be considered, apart from applying power to it, self-contained units and can be thoroughly assessed against the different rules as they stand. So you can apply In Europe, for example, a radio module is considered to be a radio equipment, so it comes under the Radio Equipment Directive. And also for North America, radio modules are specifically listed and can be certified in their own right. Now, there may be some conditions associated with that certification. It might say you must connect this type of antenna to it, and the manufacturer has to provide some very explicit instructions to ensure the integrator of that radio module doesn't affect the compliance of it in the way that they integrate it into the host itself. So when we put the radio module in a microwave oven, I'm just using a microwave oven as an example here, both the product on the left, which I've just called a module, but for Europe is considered to be a radio equipment, must be CE marked. And then the microwave oven, if that module is integrated into the microwave oven, is also radio equipment itself. And so individually, they both must comply with the Radio Equipment Directive. To help manufacturers in Europe, we have a Radio Equipment Compliance Association, REDCA, and they have got a really helpful guide, Guidance Note 1, on requirements for integrators of radio modules into a final equipment, a host product. These are freely available on the REDCA website, which is at redca.eu. We've also got ETSI guides. So ETSI, being the European Standards Institute, have provided guidance on how to integrate and what you should do when you build up equipment with multiple radios in the same host. And the ETSI guide itself. I'm taking an extract from the guide and I'll read it out. If the conditions in which the radio product is used in the combined equipment deviate from the assessment conditions, then the manufacturer should reassess the combined equipment against Article 3.2 of the RED. And this is really trying to help the final equipment manufacturer understand what they need to do. They've bought a radio module and just integrated it into their host equipment. On the FCC side, on the grant of authorization which is issued, so the TCB will issue the grant of authorization on behalf of the FCC, you can see in the blue box in the corner there the limitations on a radio module. So in this particular case, it's a limited radio module, and it tells the integrator what they must do and what rules they must follow to make sure that they don't invalidate the approval that was issued to this particular manufacturer. The FCC have also got rules on if anything is modified, what you need to do, such that we get a modified certification that applies to the device itself. In terms of limited module approval, there are certain conditions, and I've just put those on the right hand side just to help you there. So when we're thinking about third-party radio modules themselves, some of the things that we should be thinking about when we're integrating those into the host equipment is the fact that the fundamental or unwanted frequencies can start resonating if you start changing track lengths and PCB layouts. When you put it inside a metal box, for example, if you put other electrical devices around it, then you can get reflection of those signals off the other devices, which can affect the radiated power which is emanating from the device itself. Inversely, if you took a radio receiver module, for example, embed that into another piece of equipment, it might have lots of metallic surfaces around it, then it might block some of the signal and effectively make that radio module more deaf, which will then affect its sensitivity, its ability to receive the signal. And it also, depending on where it's located or co-located with other devices, there might be blocking signals generated, so signals operating in other bands which desensitize the receiver as well. All of these things affecting the performance of the radio module when it's integrated into the host product. Each of the radio devices can have an effect on each other. So for example, if you included a Wi-Fi and a Bluetooth module in the same product, the frequency on which they operate is the same 2.4 gig ISM band. So in this particular case, if you took a Bluetooth signal and you measured it, you can see the fundamental and you can see a second harmonic further up the band. Here's another product, which is, let's call it Wi-Fi product, very close in terms of fundamental frequency, and again you can see the fundamental and harmonic. But if you co-locate those two devices in the same product, you hope that they won't have any interaction between them. However, the reality is that you can get spurs generated by creating interharmonic products, and also the amplitude of the signal can increase or decrease depending upon its phase relationship with the other devices. Equally, you can get resonances and new frequency products being generated when you bring these two things together. All of which means that you need to do an additional assessment on the final product from a radio characteristic point of view when you bring all of these different radio devices together into the same product. In terms of EMC, maybe this is a slightly better articulation of the difference between radio and EMC testing. So along the x-axis along the bottom here, if that is frequency, then typically EMC immunity testing is done outside the wanted radio bands. In band, you have a channel, let's call it the wanted channel in which your device is operating, and then you have adjacent and alternate channels. And receiver blocking seeks to put signals in these adjacent and alternate bands, and it's really a measure on how selective the receiver is to only receive the information in its wanted channel and reject all of the other signals in the other channels. So everything that's hashed in blue, if you like, is contained in radio tests, whether they be radio transmitter or radio receiver tests, and the grey boxes at either end are the typical EMC tests that you would perform. Again, talked about ETSI guidance before, but ETSI have also produced two rather helpful guides, what manufacturers need to do when they're integrating radio into non-radio type products. Part 1 is covering residential, commercial and light industrial locations, whereas Part 2 is covering industrial locations. Typically the EMC tests that we perform, again here if you took the example of a refrigerator for example, if this didn't have any radio device embedded in it, then the standard 55014-1, which is its emission standard, and -2 its immunity standard, would apply. The manufacturer is required to do an assessment of all of the different phenomena that you see down there. When it's got a radio module embedded in it, then ETSI 301-489-17 would be used. -17 simply because I've assumed it's a Wi-Fi or a Bluetooth module. There'll be other parts that apply if it used a different type of wireless technology. And you can see that essentially all of the tests are repeated. One is looking at the effectiveness of the fridge? How does it maintain the functionality of the fridge? And the other one, the ETSI 301-489 standard, is making sure that the radio characteristics, it doesn't drift off frequency, doesn't stop transmitting or receiving information, the data rate isn't affected. That's the job of the ETSI standard. So when we're looking at those, again, the radio function column relates to the ETSI 301-489 standard, so making sure the data rate doesn't drop below a certain level. If it's in a standby mode, making sure it doesn't transmit. And then on the EM 55014 side, does it continue to work as a refrigerator? It looks like it's got a drinks dispenser or water dispenser on there. Does that continue to work? Does the pump on that work? If it has a display on it, making sure that the display continues to work. Does the touchpad in this particular case still operate? All of the things that you'd need to assess from a non-radio functionality perspective. So in terms of wrapping up then, integrating a certified radio module saves development time, but an understanding of the interaction with the host is absolutely critical. Depending on the region and where the product's being sold, additional testing will be required when you integrate a radio into a host. And the relationship between the radio module manufacturer is essential in order for them to support you during the process. If there's special modes of operation that need to put the radio in, for example, or leveraging previous test reports, data, all of those sorts of things is really critical to minimizing the requirements on you as the host equipment manufacturer. Having a clear strategy for compliance is essential. So if you having, for example, or intending your product to be launched in both Europe, North America, USA and Canada, then there is a certain amount of overlap of testing, and combining it into one process can save a tremendous amount of time and money. Using an expert such as Element can really help, and we can help and guide you through what the most effective route to compliance will be. So always talk to us as Element and we'll be sure to help you out on your journey. Don't have any questions or answers for this particular session here, but as always, should you have any, feel free to reach out to us at Element and we will be able to connect you with the right people to help you bring your product to market. Thanks for listening and we'll catch you soon. Thank you.